Yeah, just be working on how do you determine if a series converges or diverges. So nth term test, geometric series test, integral test, harmonic, and p-test. There we go. So 9.2 and 9.3 basically is what that one is over. That'll be this Friday. Yeah, any questions there?
What's the p-test?
So as you know, and we'll keep doing this, we'll like basically every class we've gone back and kind of reviewed everything that we've done, and we'll continue to do that today. Like, you know, as you consider these, would you try this? Would you try that? Would this even work? And we'll go through all of them. So hopefully this will all be a nice review for you to some degree as we go through all these here. So last time we talked about the comparison test. And if you remember, the comparison test is like that coach that's forever comparing his or her players to like the star on the team or the hardest worker. Like, Santi, you worked so hard. Nick, if only you would work as hard as Santi. I had to reverse that. Or, wow. Nobody else in here. I'll go with these guys. Wow, Julia, if only you would run as hard as Meg does when she's trying to make her run down the sideline to, get the pass and score. There we go. So you could say, hey, is A sub n the series that I'm trying to investigate? Maybe. Or it could be B sub n. It doesn't matter which one is in which place. You just need to make a fraction of the two of them, do the limit as n goes towards infinity, and then here's the standard we compare. If the result of that is finite, and it has to be positive because we've eliminated the negatives out of there. So if the answer is just a real number, like 2 or 1/2 or 7 or 1/7, reciprocals of each other depending if you did A over B or B over A. But if you just get a real number, then what happens is both of those series converge or both of them diverge. So they're in it together, right? So either Aiden and Logan hit the 3-pointers within the 2 minutes, or they didn't. But they're in it together, right? They both converge, they both diverge. So the key here is to compare to a series that you know its convergence or divergence, right? Because if they both converge and they both diverge and you don't have a clue about either of them, you're no further than when you started, right? But if they both converge or they both diverge and you know one of them converges, well, then you know the other one does too. Or if one diverges, then you know the other one does as well. So I put here that the series that you pick, and you're going to pick up on this really quick, I just know you will, that has an nth term of the same magnitude as the series you're testing. That word magnitude might seem a little bit vague or you don't necessarily know what I'm talking about. I'll show you in a second. This is very effective if you've got p-series manipulations, like things that aren't really a p-series, but like sort of kind of look like they might be, but they definitely aren't. You can use this very quickly. And this is super useful on multiple choice where you don't have to show work. Super duper useful. So we'll get into that here in a second. So I would like to kind of do this as a review and then pushing forward to the new stuff. So if you look at number 1, let's just do some of these in our head. So for number 1, if you thought to yourself, I would like to figure out the convergence or divergence, how about the nth term test? What would that limit as n goes towards infinity of that nth term be?
0.
Therefore, we don't know, right? No meaning attached to that at all. It means we keep going. So if I went in order, I would say maybe I should do a geometric series test. Could I use that here?
No.
Why?
It's not geometric.
It's not geometric. Remember, the geometric series is a great test, but it only works on geometric series. Geometric series has a numerical base with a variable exponent, and that's not this. It's the exact opposite, right? So then you can't use geometric series. The next thing was the integral test. Could we use the integral test?
Yes,
Why?
because we can find the integral of that.
Yeah, finding the antiderivative would be super duper easy. What would it involve? It'd be an ln, right? So I'm not going to do that one, but we could use the integral test here. Could I use the p-series test?
No,
Why?
because it's +5.
The
and
plus
that.
5 ruins that,
Does
doesn't
the
it?
2 matter? No, we can factor.
No, because you could just factor that out as a 1/2. Yep. Okay, so the plus 5 ruins the p-series test. The last one would be the harmonic series. Is this a harmonic series?
Yes.
It is, and all harmonic series do what? So we know, like right away, before we really get into this, that this will diverge. But I would like to, let's just say that either A, you kind of forgot about all those other tests, like the handful that we just talked about that you could use, or let's say that you decided, I really do like this limit comparison test. It's easier for me, or I understand it, or it works well for me. I'd like to do that. I want to approach it from that perspective. But I want you to know, those other 3 tests would work just fine. Okay? So, here's how this works. I'm going to compare to, I'll just put here as a note, I'm going to compare to 1 over n. I want to talk about why I picked 1 over n. So up there above in those little statements I mentioned, you want to compare your series to a known series that has the exact same magnitude on the nth term. So here's what I noticed. I noticed that on my 1 over 2n plus 5, I noticed that the degree of the numerator was 0 and the degree of the denominator was 1. So the difference between them is 1. So as long as I compare to a series whose difference in degrees is 1, I'm going to get a good comparison. So that magnitude, I would say, would be like the bottom's 1 bigger than the top. So if I wanted to, now this would be totally silly, but it would work fine eventually. I could compare to, so I'd have some other options here. I could compare to this.
Okay.
I could compare to this. Or how about this?
Yeah, you can do these
So between
things.
the top
Or-
and the bottom has to be 1. Is that what you're saying?
Oops. The difference between the top and bottom degrees needs to be 1. So any of those would eventually get me where I want to go. The problem would be like dealing with n to the 20 over n to the 21, like proving that that actually diverges would be a whole other problem, wouldn't it? So it would be much smarter to just use this because I already know all that I need to know about that one. But as long as the difference in the numerators and denominators degrees was 1, I could eventually get around to a good answer. Pick the simple one, but yeah.
So the denominator degree has to be 1 bigger, numerator can't be 1 bigger?
Because that matches the series that I'm trying to analyze. Now later on, like take a quick peek ahead at number 2. What's the difference in the degrees there?
2.
So that means my comparison would need to have a difference of 2,
Like 1 over n squared.
like that.
Oh, okay.
Does that make sense?
Yeah.
So not every single one of these would you do 1 over n. You just want to customize it for the particular nth term that you're dealing with.
I don't know.
Yeah. Okay. Alrighty. So I just need to mention that 1 over n is positive, and 1 over 2n plus 5 is also positive on the interval from 1 to infinity. That's our condition. And then I'm just going to go ahead and calculate this limit. So check it out. Limit as n goes towards infinity. And like I said, it doesn't really matter which one is put where. So I'll just say 1 over n over 1 over 2n plus 5. This equals limit as n goes towards infinity of, I guess it would be 2n plus 5 over n, which equals what? So you could do a L'Hopital rule here if you want. Why not just use the degree trick and immediately jump to the answer? 2. Degrees are equal, so it's just the lead coefficient ratios. This is the thing you guys tried to do on the loop quiz when it wasn't really limit as x goes towards infinity. Remember? Yeah. So
That was fun.
What if you did it the other way though, and you had like 1 over 2n plus 5 over 1 over n?
sure,
Then the limit as n approaches infinity would
So
be
if you-
over,
it'd be 1 over 2.
yeah.
It'd just be 1/2. So if you did it that other way, you would get 1/2 instead of 2. So the point here is that 2 is positive and finite.
So it doesn't really
So
matter if it's
If it's 2 or if it's 1/2 or 1/3 or 3/4 or whatever, as long as that end result is a positive number, which it really has to be if we've set this up correctly, and finite, so it's got to be just a real positive number, whatever it is,
It works, okay.
whatever it happens to be, if it's real and positive, then both series converge or both series diverge.
We get
So-
to do the whole L'Hopital's, like,
No, just say equals 2,
we don't
please.
have to prove it then.
No, there's a multitude of ways to do that. And unless it's some free response that says, I don't even know how I would word it if I expect. I would so hope that you'd be able to look at this one just with simple polynomial stuff and just say equals 2, done.
Well, I just didn't know, because last year you were like pretty strict about the notation. I don't know if they're the same way this year.
Well, but see, I am actually being really strict about the notation here. Like if you told me that this equaled infinity over infinity,
Yeah.
we have an issue,
Uh-huh.
right? Because later on you're going to tell me that it equals 2. Now we have a real contradiction here. So you're going to find, especially with these, I think here's the philosophy. With these series, we're saying, you've seen L'Hopital's rule a lot. But we're also hoping that you know how to not have to use L'Hopital's rule to get there. Because you don't have to use L'Hopital's rule here, right? Do you remember this technique?
Yes.
Couldn't you just divide every single term by n? Simplify and then apply the limit? So you can do that too. So L'Hopital's rule would not be the only way you could do this. And so I don't want to say you didn't show L'Hopital steps. We have a problem. I'm going to be open on how you did that, including the whole ratio thing because the degrees are equal. And if you think about it, with a limit ratio test like this, if you did it right, shouldn't the degrees be equal every single time? If you did it right, they better be equal. Because if you chose the correct magnitude, like the difference in the degrees, if they're not equal, you need to go back and figure out where you went wrong on choosing your comparison. Okay, so I'm going to say because sigma from 1 to infinity of 1 over n diverges, and I'll just put here because it's harmonic. That means that sigma from n equals 1 to infinity of 1 over 2n plus 5 also diverges. So this is one of those cases where, and we're, at this point we're done, but this is one of those cases where I don't think we would use this, right? Wouldn't we look at that? I think we'd look at this at the very beginning and say, hey, sigma of 1 over 2n plus 5 is harmonic, therefore it diverges. Done. So we wouldn't go through all this. I put this in here just so we could connect the stuff we've been doing to this. So you can see how there's multiple ways to get there. I think you'll find with number 2 and some of the other ones, you're going to say, oh, I see why this is somewhat useful. Okay, so let's check out 2. And here's where you'd run into some interesting stuff. Because if you try the nth term, I'm going to go in order again. Nth term test, what does it tell us? Right, because we head towards 0 with the nth term. So it tells us nothing. Is it a geometric series? It's all wrong for geometric. What about the integral test?
Maybe.
Maybe. It would depend on if we can find the antiderivative. Can you think about what we'd need to do to find the antiderivative?
You have to complete the square.
Either partial fractions or complete the square, depending on which way it's going to tip, if it's going to go either way, right? Because it might not go either way. Okay, so if that doesn't work, integral test, maybe that's either too much or just doesn't work. So we try the harmonic series test. Is it harmonic?
Nope.
Why?
The negative 4 plus.
No.
Or
'Cause-
harmonic? No, wait.
Harmonic.
He does not, it was not like
There's one term that kind of messes up
the squared.
the squared, right? Harmonic has to be highest degree of 1. So it's not harmonic. What about the p series, right? P is 2, we're done.
No, because
Ah. The minus 4 and plus 5. So it's not a p-series test either. So this is where you'd arrive at maybe a comparison. Maybe you'd say, let me do a comparison. You got to admit, wouldn't it be nice to have a graph of this or a table or something if you were going to try to compare this to something else? And you could spend an hour and say, oh man, I thought I had a comparison, but over here, like the low and the high switch now, and now I don't know what to do. this would be where you would really say limit comparison is best. Okay? And I want to talk this one through from a free response perspective and a multiple choice perspective. If this were a multiple choice, I'm hoping that this would take you 3 seconds. I'm not kidding. Okay? So check this out. I really mean that. Like, maybe not right now, but in the future, if you saw something like this, you would do it, a multiple choice would be over with. Almost before you were done reading it, you'd be done. Okay? So here we go. We've eliminated all those other tests as either not being practical or not being possible. So let's do a limit comparison. And what would you all suggest? Do you remember what I said? Compare to what?
Oh, you said 1 over n squared.
1 over n squared. Let's talk about y. What's the degree of the numerator? So I want to match that. My degree of my numerator is 0. What's the degree of the numerator?
0.
No.
The denominator.
N squared.
The denominator.
Did I say numerator?
Yeah, I think you might.
What about the denominator? What about the numerator though, Peyton?
That would be 0.
Numerator? Okay, so then denominator, sorry. Denominator is? 2. That was not a trick question. That was me tricking myself. So then I wanted to match that, right? So degree 0 over degree 2. I'm going to try to match that in the simplest possible way.
So if the equation was like n over n squared, would you compare it to n over n squared? Like n over like...
I would compare it to the simplest version of that.
Which is
1 over n. Yeah, so if it was n plus blah, blah, blah over n squared plus or minus blah, 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 I would go with 1 over n. And the reason being, I already know the divergence convergence of 1 over n. If I do n over n squared, well, I'm going to have to say, all right, it wouldn't be that hard to do, because I would just say, hey, n over n squared is equivalent to 1 over n, which is harmonic, which diverges, but it would add 1 step into the mix.
You're just trying to match the difference.
Trying to match it in the simplest possible way. Okay. So can I go in a little different order this time? Here's a way you could approach this. You could say, ladies, listen up. I'm going to take a slightly different route here. So I'm going to say, compared to that series right there, which does what? Converges or diverges? Which converges. And how do we know that that series converges? It's a P series, and there it is. So I'll put P test, P equals 2, which is bigger than 1. So that's all the reasoning that I really have to show. Just say, hey, it's a P test or a P series. P is 2, which is bigger than 1. So I've established that that series that I'm going to compare to converges. And I just at this point need to show my steps. I need to say that 1 over n squared and the original, they are both positive on the interval 1 to infinity. They're both positive. And you don't really have to prove that. You just have to essentially make note of it. Say, hey, I know this is a condition and it's true. Yay. Now we're going to compare. So limit as n heads towards infinity. And I don't remember which way I did it last time. I'll do it this way. I don't know, 1 over n squared. I think this is how I did it last time, isn't it? Yeah. There's no rule on the order in which you compare. So it'd be this. And when you calculate that limit, what do you get? It is 3, which is positive and finite. Therefore, my original series, I'll put it here. Therefore, the original series also converges. So please be really careful that you give an explanation as to the significance of the number. So if you did not put the stuff that I'm highlighting, if you just said, hey, that limit equals 3, therefore that series converges, you're really leaving off some important reasoning, and that is that 3 is positive and finite. Because somebody could read that and be led to believe, oh, okay, so if that number's 3, that has very big significance. But if it was 2, then that means something else. And that's not true, right? The fact that 3 is positive and finite, it's the positive and finiteness of it that's important. Okay. So, can I explain to you what, I guess I'm about to give you, I'll give you the multiple choice hack, if you will. If I'm looking at that, listen please. It's hard to listen when you're talking. I'm trying to give you the easy button here, honest to God. I said earlier that this should take you 3 seconds, this multiple choice. What I would notice here is, very quickly I'd run through all the geometric stuff. Like, I'm going to hopefully be able to identify that instantly. It's not geometric, don't want to do an integral test and all that. And once I arrive at this, once I say compare to 1 over n squared, I'm done. Because I know that 1 over n squared converges due to the p-test, right? And so if I make a valid comparison, which I am, I know that the other series will also converge. So if I just look at that difference in the degrees, if the difference in the degrees is bigger than 1, you're done, it converges. If the difference in the degrees is 1 or less, you're done, it diverges. So think about what you would compare to. And we'll do some more examples here in a second. But that really comes down to simply, what am I comparing it to? As long as I have done that comparison accurately, you can use the convergence or divergence of that to immediately come to a conclusion. This is in multiple choice format, right? It's free response. You're going to have to explain yourself a little bit better. Multiple choice, you don't have to explain anything. You just say, hey, look, the difference is 2. Bam, done. Seriously, that's all you got to do. So, and these do show up in multiple choice, for sure. Both for me and AP folks. Yeah.
Could you use the limit comparison in place of the direct comparison
Yes.
in any situation?
Well, unless the direct unless your series involves like some non-polynomial element.
So like now and or something.
Yeah. But if it's just polynomials all just combined together, then yeah, you definitely can. And highly recommended, especially in multiple choice. Definitely in multiple choice. Okay, so let's do this. Let's test you out for number 3. So, number 3. Let's pretend for a second. We can do the full go here in just a second with all the free response sort of stuff, but let's just pretend this is a multiple choice question, and this was part of a set, like determine which of the following converge or diverge or something, and you're trying to decide, does this converge or diverge? Here's how fast this could be. What is the difference in the degrees? 1/2. Therefore, diverges. Done. If it's multiple choice, that's what you do.
Between top and bottom.
Yep, look at the top. And obviously, the one thing I'm not saying, I hope it's obvious enough to not have to say, but I think it's worth saying still, if the degree of the top is bigger than the degree of the bottom,
It's just gonna.
automatic diverge because of what test? Nth term.
Yeah.
Right, so when I say difference in degrees, I'm always assuming that the denominator's degree is bigger than the numerator's degree. Otherwise, we wouldn't even be here, right? We would just go nth term test done. Okay, so would you guys please try number 3, the free response version of the answer. Okay? Ready, set, go. Was this back in the days before cell phones?
Yeah, when I was like 6 and I
Yeah.
didn't have a cell phone.
Dad? All right. So,
Say, I was 7 last year.
here's where I'd start off for number 3. As you guys know, there are a ton of different ways you could combine to get to that comparison. Why would I pick this one?
Because it's the same magnitude.
Yep. And it's something that I already know about. It's the simplest comparison. I'm trying to make things simple, not more complicated, because it's already complicated enough. So this one, this series does what? This diverges. And then what would we always have to support ourselves with some evidence? So I'm going to say because why?
P is between 0 and 1.
P equals what?
1/2.
1/2, that's right. And make sense, P series? Okay, so then want to make note that these two are both positive on my interval from 1 to infinity. And then we calculate our limit. Which goes here. As I walked around, this was probably the number one comment is, what do I do with that? And here's one thing you could do. You could just rewrite it as one big fraction inside the square root. And what does that equal?
Root 1/3.
Yep, square root of 1/3, which is positive and finite. Therefore, because my comparison diverged, we can say therefore the original series also diverges. Peyton.
So on a quiz or a test, if we get like the number wrong, like
Yeah.
if we got like 7 but it's still greater than 0 and finite, would we count points off for that?
For sure, yeah. So like your analysis has to be correct, but typically if you say you did get some incorrect number, but it still fit, and then you had a good conclusion, certainly would count that in your favor.
Okay.
But yeah, the numbers have to be right. It is math. We do want to be precise and correct as much as possible. All right, if you haven't already looked at number 4, please check out number 4. And you can, there's maybe like 5 or 6 of these. I don't know exactly. So feel free to just continue if you.
You know how precise I was last year? I wrote 2-ish as one of the answers on my test.
2-ish. At least did you do the squiggly equals?
No, it literally just equals.
Because squiggly equals literally is a technical way of saying 2-ish, right?
I mean, 2 could be close to 7.
Depending on your definition of close, right?
Relatively
Yeah.
close.
Sure.
I mean, depending on our size.
For sure, yeah.
Right.
If the scale goes all the way to 10 billion, then it's
Mr.
quite close.
Wilder counted off like half a point for that. And that's it. What a great man.
Well, it just depends.
I
Depends.
did the rest of the math right. I just didn't.
So greatness only depends on your perception of mercy.
Could that work in a Christian perspective?
Just trying to think. I said it out loud because I wanted to think about it.
Yeah.
I don't know. We've swung greatly in the direction of God's mercy. You realize there's no negotiating with God? Like, God, I've been really awesome. I helped Aiden with his math, and I said something nice to Justin. All of your righteousness is like filthy rags. Eesh. So God is merciful, and he's ultimately holy. So yeah, I mean, that's a interesting philosophical question. I don't know.
Would I do for this? Would I do 1 over n cubed or
Back
1
to
over
math.
n to the 5th?
For number 4,
Yes.
I would go cubed because top is 2,
Yep.
bottom's 5, difference is 3.
Okay, so not based on what it actually is, just based on the difference.
Now you could compare it to n squared over n to the 5th,
1 over n cubed.
and that would eventually work fine.
Okay.
It's just that with n squared over n to the 5th, you'd have the additional step of like, okay, well this equals 1 over n cubed. It wouldn't be a long step,
Yeah, but you don't.
but you might as well just make it simple to begin with, if you can. Hey, when you guys looked at number 4, did anybody look at it and in 5 seconds know what the conclusion should be?
Yeah.
Should be.
What should it be? It better converge, that's right.
Is
Keep-
there any what kind of situations would a limit comparison test give us something that either wasn't positive or wasn't finite?
Well, positive we should be able to handle because any situation where all the terms are negative, you just factor the negative out. So that shouldn't be an issue. And then the other thing that Peyton mentioned is if you get something that's not finite, to me, that probably means that either you miscalculated your limit or you're comparing to the wrong thing, right? If you didn't match the difference in the degrees correctly. We're going to find out in the next, and we'll probably talk about this a little bit today. I think, yeah, we'll have time, I believe. We'll find out that and we talked about this on day one, some series alternate. They go plus, minus, plus, minus, plus, minus. That would not work here because there's no way to factor that out. So it's either you've misapplied the whole concept to an alternating series, or you didn't factor the negative out of one of them, or you miscalculated the difference in the degrees, like Peyton referred to, 2 minus 1, or 3 minus 1, or 5 minus 0, or whatever it happens to be. Calculate that correctly, you should be good. That's why I say this is super quick and easy for multiple choice, because if you're like, hey, look, polynomial, difference is 5, converges, moving on. Polynomial, difference is 1, diverges, moving on. So multiple choice, this is really the easy button. It really is.
Kind of related.
Say again?
I have a question.
Yeah.
Is it through limit comparisons?
The quiz on Friday? No, quiz on Friday stops at 9:03, so there's no comparison on the quiz at all.
Okay, so
Wait, so
it's
can we
just
use,
the.
So, good question. So anything that's valid, like if it's good math, it's good math, unless I say, please use the P-series test to blah, blah, blah. Then you kind of have to use the P-series test. But good math is good math.
Like,
Right.
hey,
So I'm going to say this right now. I'm going to say that direct comparison is almost always never the easy route. Direct comparison is almost always the harder choice, no matter what, most of the time. Limit comparison could be the easy button. It very well could be. And if you do it correctly, get all your conditions in there, you're good. What you can't do, and what I'd caution you on, sometimes people hear me wrong, or sometimes people are talking and they don't hear me at all. Like if you, let's say it's for your response, and you thought, I'm going to do that limit comparison thing, and here's your reasoning. You say, it converges because the difference in the degrees is 3. Like, you haven't really addressed anything. You basically set up your comparison, but you haven't really addressed that method at all. So just be careful. Make sure you're doing it right, is what I'm trying to say. But if it's good math, it's good math. Never going to argue with you on that, unless it goes against the directions. You're good. Yeah. Okay. Oh, you had a question.
So, you know how it's like
I'm sorry, Santi and others, could you quiet down just a little bit? I can't quite hear Julia.
So, for this test, don't we have to prove that it's like greater than 0 on 1 to infinity?
You just have to state it, essentially.
Because at 1, what if this one not be greater than 0?
Oh, interesting. Hey, I don't know if they picked up on that or not. Let's look at it. Hey guys, check it out. Julia brought up a very good point. So let's say we compare to sigma of 1 over n cubed. Does that make sense to you all? Difference of 3 on the overall degrees. Okay. Which does what? Converges. And since these are all variations on the p-test, we would say because p equals 3, which is bigger than 1. Good? So what Julia said is, wait a minute, don't we have to prove the positivity of these? And if you were to say that 1 over n cubed is positive on the interval from 1 to infinity, that's true, is it not?
Oh my gosh.
This is an easy workaround. We just want to be precise. And n squared minus 10 over 4n to the 5th plus n cubed is positive, but not on the same interval.
Well, between 1 and 4.
Do we have to figure out the exact?
Well, it's not that hard. Root 10. There we go. So on root 10 to infinity,
That doesn't matter.
and as long as this is a subset of that, or that is a subset of this, we're good. Right? Because we're talking about long-term behavior. And if you think about it, all we're really concerning ourselves with is, does this series converge or diverge? So if you take converging and you add a bunch of negative numbers, like a finite number of negative numbers to it, we still get converging, right? So that space between 1 and root 10 would be a finite number of terms in a series, right? It would be,
It's in between the 3 and 4.
yeah, either 3 of them or 4 of them, depending on how you want to look at it. That would represent a finite amount added onto a converging series in this case. Doesn't really change anything. So I'm going to say, but Julia, I will say that kind of attention to detail is good. Wait a minute, what about this? You're asking the right questions. Stupid detail. Sometimes the details are everything. Yes, ma'am.
If I put on 3-ish to infinity on a test,
3-ish.
Instead of root 10.
Just do the squiggly thing.
on
That's-
approximately 3.
Everybody knows what the squiggly thing means.
Well, but 3-ish is more fun.
That was
Should be
the
classified as a legitimate
most
mathematical.
condescending
Right.
chuckle I have ever heard.
Why don't you publish that in some math journal? The value of ish. We'll all read your article and clap and
I
appreciate what you wrote.
I won't. Well, it's 3-ish.
It's gonna be 800 pages, will you?
I just won't.
How many pages are you going to write on ish?
800.
800-ish.
800.
From 2.
Which might be 1 or 2 even,
The
right?
number of pages is gonna converge though. That's
On
all.
the interval from
It's not gonna
imagine a
close
book that
bracket
doesn't
2.5
that like diverges
to bracket that diverges.
Imagine
just, like,
still flipping
Consider that
pages.
to
be 3-ish.
3-ish.
David Copperfield felt. And ish is from
That's how
n
private prejudice
minus
is.
Every time you flip a page, there's another 5 pages that appear behind it.
Yeah.
Because there's an ish.
Like for every page turn, 5 more.
Okay, so here's how you would conclude this. Hopefully you're starting to get into the rhythm and see the consistency here. Why don't we do this? I don't know how much you showed on number 5, but let's finish this one off with what would you do if this is multiple choice? For number 5, what is the degree difference between the
1-ish.
1-ish? But that's really important. Is it bigger than 1-ish, or less than 1-ish?
always greater than the number you say.
Okay. I did not know.
Yes, it is.
I didn't know that was the
800
standard.
pages is
What
gonna
about
be about.
2.9?
So this would be chapter 1 in Peyton's book, right, or Peyton's journal. Hey guys, so listen. Here's all you do. You'd say the difference is 3/2, which is bigger than 1. Therefore, the series does what? Converges, right?
Okay, ooh, I was like,
Converges.
converges.
Yeah. Yep. Okay. So all of this was just basically, hopefully, repetition to get you thinking along these lines. Again, this doesn't work in every single case. This does not work you could make this work with a geometric series. You could make this work with a geometric. But then if you have like non-polynomial sort of things beyond geometric, not going to work as well. And then obviously if there's some other like non-polynomial elements like sines or cosines or e's or anything like that, this is not going to work well at all, right? The degree thing gets lost in that. So the other situation where it doesn't work is in what we call an alternating series, and I want to just give you a brief preview of that. There's some lovely practice questions. Here it is. So I want to just plant this thought in your mind before you go.
All of us, we haven't even seen it yet.
This is going to work out great. I'm going to use the board for this. So an alternating series is a series in which the terms go plus, minus, plus, minus, plus, minus, or minus, plus, minus, plus, minus, plus, right? They alternate signs. That's why it's called an alternating series. So you're going to find that the alternating series test is kind of the soccer mom of the tests. Basically, if you're on the team, you get a juice box, a bagel, and a trophy. Okay?
Sounds like the dream. I don't.
So,
Three sons more.
so listen, more or less with an alternating series, the alternating series test, you're going to find that as long as the series can sneak its way past the nth term test, like in other words, it can kind of get on the team. Remember, the nth term test is basically just kicking people off the team, and that's it, right? So if the series can at least just get on the team, they are going to converge. And here's why. The alternating series would look like this. It would be here, here, here. Now this one passed the nth term test, right? You see how it's heading towards 0?
Sure.
But it's flipping sides each time? So here's the deal. Remember how I told you that with a typical positive term series, the convergence divergence depends on the speed that the series approaches 0? Too slow, not fast enough, or fast enough. This, do you see how every time the sign goes from positive to negative to positive to negative, doesn't it slow the growth? Because what's a positive plus a negative? Isn't it always less than the positive?
Yeah.
Okay, and then we add a little bit, but then what do we do next?
We subtract.
We subtract a little bit. And then we add a little bit, but then what do?
We subtract
We
a little
subtract a
bit.
little bit. And so that plus minus plus minus plus minus property allows the speed to be fast enough as long as the nth term is heading towards 0. Like that's the gist of the alternating series test in a nutshell, which we'll revisit next time. Question?
So a sine or cosine graph is essentially symmetric about the x-axis, right?
Sure.
For an infinite sum at least.
Plus 1 minus 1, plus 1 minus
Right.
1.
So would that converge? I mean, it never really actually like converges.
It
Or
would,
would it just diverge at 0?
it would diverge because the nth term doesn't go to 0. The nth term just goes between -1 and 1, -1 and 1.
Right.
But think about this one. What if you had a series that looked like this? It's like a cosine graph, right?
That's gonna,
That approaches
oh
zero.
shoot.
But it's going to approach 0, is it not?
So that's
Yeah.
something we should talk about later.
Well, I'm just thinking like a straight cosine graph.
Yeah.
It would diverge, but the infinite sum would be 0.
Why would it diverge?
Because
Cosine graph?
Because it never.
Wait, why
No,
would it
cosine
diverge?
graph
It would
converges
converge
to
to
zero.
zero.
Cosine graphs and.
Is it time to go
sine
yet? I
Yeah,
thought,
it is.
I thought I was already over, but is it?
Yeah.
Okay, you guys are all good to go. We can talk about this more if you want right now, but I just didn't want you all.
Cosine stands for converges.
So,
Hey.
You're like, no.
Pipe down.
That has no